Hi, this session is about ArcGIS Urban, its software architecture, and the Urban API. My name is Michael Vandenberg, and I'm the lead developer on ArcGIS Urban. In this session, I will explain what ArcGIS Urban is. I will talk about the software architecture and components we use. I will talk about the Urban API and give a demo that's using ArcGIS notebooks and PyPRT. And finally, I will talk about a library we have called React Scene View and give a little demo about that. First of all, what is ArcGIS Urban? Urban is a 3D cloud-based urban planning tool. It's a web application where people can design 3D scenarios, and it also allows to enable digital engagement. Urban contains three types of items. The first are zoning and land use plans, where urban planners can design the parcels, the zones, the zoning regulation. They can generate plausible buildings within those regulations and do estimations on the capacity of the zoning plan, of the zoning changes, as well as see a visual representation in 3D of these plausible buildings. Then Urban also contains projects which can be visualized citywide on the map. Projects are usually on a parcel or on a couple of parcels and have 3D architectural models of the project that is to be built. Then Urban also has indicators, which are data layers and visualization on different topics, which can be shown and used in the context of plans and projects. Now we'll show that. So to try Urban, you can browse to ArcGIS Online, go to the Content tab, and granted you have an Urban license or a trial license, you can use the Create button to create an urban model. Clicking this button and entering a name for your model will open the Urban web application and let you initialize an urban model. To have a nice trial experience, we have set up 4 trial example cities which you can use to jumpstart an urban model which is already filled with content. For this demo, I will set up Boston. And then the application will create the urban model and set up the necessary feature services and fill them with the example data for Boston. Once the model and the feature services are set up, Urban will open the map with a 3D representation of the city. There is this satellite visualization with meshes, or there is a schematic representation of the city. There's also pins representing the different plans and projects that are scheduled or being designed around the city. I can also browse these plans and projects by clicking on the buttons here on the left. For example, I can click on this Museum of Fine Arts project, and Urban will then zoom in to the project and show a 3D model for that project. In this case, it's an extension to this museum building, which you can see right here. I can also click on a plan. In this case, a zoning plan for the South Boston Dot Avenue, which will then open up a visualization of the plan within the context of the city and the projects. In the side panel, I have a name and a description, a thumbnail of the plan, as well as the option to switch between different scenarios. For example, this scenario we're looking at right now is if no changes are made to the zoning, then this industrial neighborhood will just continue to be developed with industrial buildings. However, this planner has made a second scenario where zone changes are proposed. When I click on that scenario, I will see the new zoning colors, as well as plausible buildings, which are an estimation of what the resulting zoning could look like, with buildings with different colors for different space uses, like residential, retail, office space. Urban also shows different capacity metrics for this scenario, a projected change in population, jobs, traffic, energy use, and so forth. Then finally, the third type that can be visualized in Urban are the indicators. So for this example, I will click on the flood hazard risk indicator, and this will load a data layer with flood hazard risk and show a legend and this can be used to communicate this information to the citizens, but it can also be used as a planning tool to be analyzed in conjunction with designing a plan or project. It is also possible to attach charts as ArcGIS dashboards to an indicator in Urban. Now I will talk a bit about the software architecture of ArcGIS Urban. So on the back end, we are using ArcGIS Online and its feature services using the ArcGIS REST API. On top of that, we have built an Urban API, which lives in the Amazon cloud. And on top of that Urban API and the ArcGIS REST API, we have built the Urban front-end application, which I've just demoed. This front-end application is built as a React Redux application. We are also using Redux Saga as a side effects library for the visualization, and for GIS operations, we are using the ArcGIS API for JavaScript. Then we are also using the CityEngine PRT, the procedural runtime, to generate these plausible buildings in 3D, and this is compiled to WebAssembly and then integrated into the application. This front end communicates with the Urban API, which is run in the Amazon cloud. This API is a GraphQL API, and it is using Apollo, and it is interfacing with ArcGIS Online using the Esri REST.js JavaScript library. Now, the reason why we chose to create an API and not just directly interface with the ArcGIS REST API is, first of all, to reduce complexity on the front-end application. There's a lot of operations that Urban does that don't necessarily need to happen on the front end, such as creating a project or a plan. Another reason for us to create this API is for integration with other applications. And finally, it is also a gatekeeper of the data model, so that applications cannot just write any data into an urban model. This data is validated. And that is also one of the reasons why we use GraphQL. So GraphQL allows us to do tailored requests, which is quite useful for the urban use case, because a typical query would be, for example, to request a scenario of a plan with all its parcels and its zoning regulation. And this is a typical request you can assemble in GraphQL and get that tailored response. And another thing we like about GraphQL is the introspection. So you can look into the API and discover the data model that way. Then, like I mentioned, quite important, the validation and type checking, so that the API can work as a gatekeeper to the data model. And then finally, very useful for the front-end development is to get detailed error messages of what went wrong in case something went wrong. So I've mentioned integration with other applications, and we already have a couple of examples of that. CityEngine is an application that is able to sync with the urban data model and, for example, load plans and sync them back to urban. There is also the Urban Connector, which lets users sync their data between ArcGIS Pro and Urban. In the future, we can also imagine third-party applications, for example, permitting systems, to use the Urban API to populate plans and projects in Urban. So I'm going to briefly show an example of the Urban Connector in ArcGIS Pro interfacing with the Urban API. So here I have prepared a data layer, which I want to show in Urban. So I select the Urban model. I want to save it to the name, the description, and then run the Urban Connector. And this will interface with the Urban API to create this indicator item in the Urban model. And then in the Urban model, in the Indicators tab, this population density indicator will appear and open. Just a simple example of an external application using the Urban API to interface with the Urban data model. If you'd like to start trying the Urban API, we have a documentation page and a playground where you can learn about the Urban data model, you can learn about API patterns, and you can use the playground to try queries and play around with the API. So this is the Urban API documentation page, which contains a bunch of useful information on how to use the API. It explains, for example, how to set up the GraphQL endpoint. It contains some information about how the Urban data model looks like. For example, it explains the concept of an urban model, which contains many urban designs, plans, or projects, which contains an urban database that is a system of records of the current zoning, the parcels, the projects, also the indicators, and it contains a configuration of the urban model. It also explains the data model of an urban plan, which contains branches, what we call scenarios. Inside each scenario, you have parcels, you have zones, you have overlays with various types associated with them. Similarly, we have projects, which can have a status, which have scenarios or branches, and each scenario can contain different symbols and buildings to visualize that project. Then the page also explains the different API patterns we have, which are queries and mutations, and I will give a demo of this. Then there is also a link up here to the GraphQL playground. This opens up a page where you can assemble a GraphQL query and run it and then see the output. In this case, we queried all the accessible urban models, and there's a list of urban models which are accessible. You can also use this playground to look into the schema and to look into the documentation of the different queries and mutations you can do using the Urban API. For example, there is a mutation to create a plan, which then you can use and play around with in the playground and create a plan in Urban. I will now give a demo which uses, for example, this create projects mutation to create a project in an urban model. However, I will demo this in Python in ArcGIS notebooks. So the demo I would like to give uses ArcGIS notebooks and Python to access the Urban API, which I think is quite useful for developers. And I will also use PyPRT to generate a building for the project. So the demo I'm going to give has 3 steps. The first step is to create a project in Urban and give it a study area. Then we will use PyPRT, which is Python bindings for the procedural runtime of a CityEngine. We'll use this PyPRT to generate a 3D model of a building and then upload this 3D model and attach it to the Urban project. And finally, we'll add some trees to this Urban project. So PyPRT, like I said, these are Python bindings for the PRT, for the CityEngine procedural runtime. What this does is it lets you input a geometry, choose some attributes, load a rule package, a CityEngine rule package, and out of that generate a 3D model. This 3D model is generated as a scene layer package and can then be uploaded to ArcGIS Online, where it becomes a scene layer that can then be consumed in the platform. Here is a link to some documentation about the PyPRT. This explains a bit what it is, how you can install it, and then use Python to start generating 3D models. It's quite interesting. I recommend having a look at this. So then for the demo, so I have prepared an ArcGIS notebook for this demo where I will walk you through project creation using the ArcGIS Urban API. The first step is to install GraphQL library and a PyPRT library. Then I will import the GraphQL operation and endpoint. I will import the Urban schema, which you can, there's instructions on how to download this in the API documentation. I will import PyPRT and I will import some ArcGIS Python libraries to do some operations on feature services. Then, once everything is loaded, the first step is to set up the GraphQL endpoint. This has a URL. This is the Urban API URL, plus, of course, the security token. Then once the endpoint is set up, I can start the first operation, which is a mutation. I'm going to create Urban Design Database. This is a database in which I'm going to create my project. I have to pass in the Urban Model ID. This is a portal item ID of the Urban Model I want to populate with this project. I'm giving the project a name, of course, type project. This is setting up the feature service in the background where I'm going to create my project. This can take a while. Then I will grab the portal item ID of the newly created design database from the response. And now I've set up the design database where I will create this project. First of all, my project should be defined by a study area. I've chosen to use 3 parcels in the city of Hardyville on which I will create this project. I will load these parcels from a feature service. So here I've loaded this feature service with this ID that has the 3 parcels that I want to use for my project. Then here is some Python code that will query those parcels and join them, union them into a single geometry, which I will then use as a study area. So it queries the parcels and it then adds the geometries to a list and creates a union. And then this will be the study area that I want to use for my project. Then I have to choose some attributes for my project. For example, the name of the owner. I will use my name, my username, then a name, a start date. This is a timestamp, an end date. And then, quite important, I'm adding a featured flag here, which will, in the Urban user interface, it will feature my project at the top. So it's easy to find because Hardyville already has hundreds of projects. And like this, it'll be easy for me to find my project featured at the top. And finally, I use the study area as a geometry of my project. This is how it works in the Urban data model. The project is defined by a study area. And then I will set up the second mutation, which will create the project in the design database that I've just created. And I will request a return field, a global ID, which I can then use for further operations in this demo. So now the project has been created and I can grab the global ID from the result, and then I can create a first scenario in this project. So to do any kind of design in Urban, a planner project needs to have a scenario. In the data model, we call these branches. So I'm going to choose some attributes for this scenario. I'm going to call it scenario 1. I will give it a description. Dev Summit 21 demo scenario, has an owner name. The order is in case there are multiple scenarios to choose in which order they are displayed in the user interface. I have to attach the scenario to the project I've just created. And here existing, this is a Boolean indicating that this is a future scenario and not an existing conditions scenario. So again, here I use the Urban API to create a mutation, which will add this branch to the Urban design database and attach it to the project I've just created. Again, I request a return field, the global ID, which I can then later use to upload data to this scenario. So there, the scenario has been created, and now I grab the global ID of the scenario, and now I I've successfully created my design database with my project and a scenario in it. So I can go to Urban and browse the projects to look for this newly created project. First, I will use this content toggle here at the top to refresh the content on the map. So you see the pins are being reloaded. And then if I click on projects, I see a list of my projects. And here with the featured projects is the primary school that I've just created. If I click on that, Urban will zoom to the pin for that project. There's not much to see now. There is the pin. If I hover on it, I see a highlight of the study area. I see the name, I see the start and end date, and I see the description that I've typed. Now I want to take it a step further and populate the project with a building. And like I said, I will use the PyPRT to use the CityEngine procedural runtime to procedurally generate a building for this project. In order to do that, first of all, I need a footprint for my building. I will load this from a feature layer that I've prepared. So here, this feature layer contains one polygon that will be the footprint for the building I want to create in my project. So then I will query the layer to get that geometry. And then I have to initialize PRT. Then I use the function ArcGIS to PyPRT to convert the feature to the initial shape geometry that is needed for the PRT. Then I have to set up the options for the result. So where I want to save the generated building. I have to give it a file name. Let's call it building 123. In ArcGIS Online, it always requires a new file name. It throws an error if the file name already existed before. Let me rename it down there as well, building 123. That's the file name of the exported scene layer package that I want to create. And then there are some options for the scene type, the spatial references, and so forth to create the scene layer package. Then the PRT needs not only the initial geometry, it also needs a rule package, which has been prepared using CityEngine. This contains the procedural rule that defines the procedural building, the procedural generation of the building. Now that all that's loaded, so the initial shape, the PRT, and the rule package, I can run the procedural generation on that shape. This now generated a 3D model and saved it as a scene layer package. So this is a file on ArcGIS Online that got saved with this file name. And then the next step is to upload that file to ArcGIS Online and publish it as a scene layer. Now the scene layer package on the backend gets baked into a scene layer, which can be consumed in the scene viewer or can be consumed in Urban. This typically takes a minute. There, so now the scene layer is ready. And for example, I can visualize it on the map. Using the scene viewer. So there we go. This is the procedurally generated building based on the footprint with some windows and a nice gabled roof. This looks great for my project. And this is a scene layer package in the platform, which I can then attach to my urban project. So to do that, I have to do another mutation using the Urban API. What I'm going to do is I'm going to mutate my scenario. So I pass in the global ID of the scenario, and I pass in the portal item ID of the published item here, the scene layer. And then I will update the scenario, update the branches with these attributes, and then the scene layer is attached to my project. That's all I had to do. So now if I go to Urban, I close my project, and then I open it again. Then it will not only show the pin, but also the 3D model that I've just generated using PyPRT. So now my primary school is almost finished. The only thing missing are a bit of trees. So to add these trees, I will use a vegetation feature service where I have some points defined. These are the points where I would like the trees to be located. So these are just XY locations for the trees. There's 5 points. I'm going to use a tree from Esri web style symbols, this particular tree here, which I can download from the platform. And then for each point in the vegetation layer, I will create a point in my project with a branch ID, so the scenario ID, and then a couple of parameters coming from the web symbol. So it's the width, height, depth of the tree, and the resource URL of that tree. So this is the 3D model of the tree. So this is just a simple mapping of the XY coordinates of my points with the tree symbol. And then again, I'm going to do a mutation on my urban model. In this mutation, what I'm going to do is I'm going to create point symbols on my project. So again, the point symbols with XY coordinates and the Esri web style symbol of the tree on it. So with that mutation, the 5 trees have been planted on my project. So if I'm here in Urban, I can open my project, and then it will show the study area as well as the 3D model and the trees. So there we go. Here I have the nice 3D model generated with PyPRT and some tree symbols. I can click on these things. I can click on the trees and I can move them around. I can rotate them. I can scale them. I can use Urban to add different types of trees. And so you can also add other point symbols from the Esri Web Symbols library. There's many to choose from in Urban. For example, we can add this crane to make it look more like a construction site. There's also various street furniture. And you can also go and draw some ground features like some grass and like a little pond of water to enhance the visualization of the project here. And yeah, so that's it for the for the demo using the Urban API. So now that I've demoed the Urban API, I would like to present a JavaScript library that we provide for Urban, using Urban, called React Scene View. And this is a React component, simple React component that lets you show a 3D map, which this component wraps the ArcGIS API for JavaScript, the scene view in particular, as a React component, which means you get hot reloading as you develop your application, which is quite nice. And there's documentation on GitHub. You can npm install this. There's an explanation on how to use it, and it's very simple. You import the components, and then you can, for example, create a scene view and add a web scene, or you can add individual layers, or you can add layers and a custom base map. You can add all kinds of different things to your scene view dynamically using React Scene View. And now I will give a little demo of that. So I'll demonstrate this with a little React hot reload example. So here we have a little example application. I changed the base map to satellite. You see it updating in real time. Now we will add a layer to the scene. So I just add that component, that React component of the layer with a portal item ID. This takes a moment to load in, but this will bring in the buildings onto the map. There we go. As you see, the app doesn't have to reload because it's React. It's just hot reloading these things. So here, another layer with trees. I just add it to the scene. I have to wait a moment. It's quite a large layer. And then the trees will start popping into the scene. Then we can do interesting things, changing props on the components. For example, we can add an edge renderer to the buildings layer to give these white buildings a bit of an edge. And there you see the map updates. You have to zoom in a little bit to see the edges appearing on the buildings. And then I can go and make changes to that renderer. For example, I will change the fill to pink and save it, and the buildings update just like that. Back to white, and I will try now a different edge color, for example red, and then the buildings have red edges. So this makes it really easy to quickly prototype React applications with the 3D map. You can quickly try out things and see the results immediately, just like you would create any React front end. So here I add some UI components like a compass and zoom buttons, and you can just see that as you code. Now I remove the trees and they're gone. Now there's some really cool stuff inside React Scene View. For example, we have some of the measurement tools from the JS API. So I can, for example, quickly add a distance measurement tool, and just by saving it, it's there, it's active, and I can measure distances. I can also add the slice tool and just paste it in as a component, and it's added to the scene view. So I can go ahead and make slices in 3D. So that was it. Thank you very much for listening. And please provide your feedback for this session by clicking on the session survey link directly below the video.
All right. right, so thanks, Michael, for that presentation, and welcome everyone to the Q&A part. For today, just as a little reminder, you can get the slides in the link below. So under the screen, you'll see the link to the slides of the presentation today. And yeah, we're going to try and answer as many questions as we can, but if we don't get to it, then make sure you stop by the Smart Cities and Digital Twin booth and ask some of your questions there. So let's get into the nitty-gritty of all of this. I'll start. So let's choose the first question. So Michael, what's the difference between the REST API and GraphQL?
Hey everyone, yeah, that's a very, very good question. Very interesting. I'm happy to explain. So the REST API, a REST API is an architecture where you have fixed endpoints, fixed routes that then give you a kind of a fixed type of answer, a JSON object, where GraphQL is a query language. So you can, usually you work then with just one endpoint and then you can build any kind of query. So for example, you can say, I want an urban plan with the zones and the parcels. And I want, for example, these 5 attributes on the parcels. And then you will get this tailored response. So instead of being stuck to the routes that the developers have provided for you, you can write your own queries and get that response that you need for your app. And of course, we could go on for a very long time talking about these differences, but I will just paste a link so anyone who's interested can read up more about it.
All right, then let's move on to the next question. Julie would like to know, and got 4 thumbs up on this, so I assume it's not just Julie. Can I use the API to update the attribute value of plans and scenarios?
Yeah, absolutely. So you can use the API to update any attribute value of anything in Urban.
That was a quick and easy answer. Okay. So another one with 4 thumbs up. Can you update the base data in ArcGIS Urban using the API, e.g. update the parcel layer, the tables with the zoning types and the land use types, etc.?
Exactly. So you can update tables. So these are mutations. You can also update layers and you can have geometry that you update. That all works and can all be updated in the whole urban data model.
All right, next question. Can I use the Urban API with Python? Which programming language is the best to use with it?
Yes, that's again a very good, interesting question. So yes, you can use it with Python. That's what we've done the demo in. I mean, the question came a bit before the demo. So we chose to do the demo in Python because you can make these nice notebooks. And I think it really depends on the application, because then, of course, for the Urban front end, we use TypeScript. And basically, you can use any programming language that's appropriate for your application.
Okay, so then next one, what else have we got here? I think maybe these two go together. Can ArcGIS Urban be deployed on ArcGIS Enterprise, or does it need to be in ArcGIS Online? If not, is it, and if yes, when approximately?
Yeah, the next question is a bit related, right? So the answer is not yet. At the moment, Urban is only deployed in ArcGIS Online. However, we are working on this. At this very moment, we are trying and testing and working on supporting enterprise in the first place with the Urban API. And we cannot promise any dates when that will be, but one of the upcoming versions of Urban will work on enterprise.
Awesome. And yeah, like you said, the next question I think goes hand in hand. Yeah, hoping ArcGIS Urban can be hosted in enterprise. Since our municipalities in Canada, we may have concerned about some confidential data that would be in ArcGIS Online, as data store is in the US and there's some legal issues. So yeah, so coming soon.
Yeah, so that's like a fair request that we see a lot. And that's why we start work on this. I mean, it's not super straightforward. We first wanted to build this API so that we have kind of a solid backend. And then the next step is to make this API compatible with enterprise. And then for the front-end application, then there isn't a big change to support enterprise. So we have like a solid architecture to support enterprise. That's why it takes a bit longer, but it is coming.
All right. Next question. Webhooks on feature service doesn't work on Urban feature service. Is it possible to set a trigger using the API?
So I believe webhooks is a very new feature. So we would have to look into that, why it doesn't work straight away. We haven't tried this yet. And on the other hand, we are planning to support this also then through the API so that you can subscribe to a model or to a plan. So this will be coming.
Okay. So, why are scenarios called branches in the data model?
This is an excellent question. And so the honest answer is that when we were designing Urban at the very beginning, we were not sure if we should call it scenarios or variants or alternatives or something else. And we thought it would be smart to call it something that no.
All right. Then what is the integration and or overlap with CityEngine? That's a good question.
Also, again, an excellent question. So we have kind of integration in two directions. So as you know, we are using the procedural runtime in Urban, and we're using CJA rules inside Urban to generate these 3D buildings in our plans. So there's like this code base of CityEngine that is being used in Urban and that we integrate with. And then the other way around, CityEngine is able to open Urban plans and edit things like parcels, make edits on the data model. And the goal, of course, is to expand this support further so that we in Urban support more CJA rules, more visualizations, maybe even custom ones, and that CityEngine also has better support to open content from Urban and do advanced edits, right? That CityEngine has many more options, and then push those edits back to the Urban data model.
Okay, so we have two more questions currently. maybe these are questions then that will have to might have to be asked again in the expo. But so let's try anyway. First one, how do you balance design user experience decisions in ArcGIS Urban in relation to providing users a web accessible experience? This must be a significant challenge point for ArcGIS Urban given the visualization of the tool. Can you elaborate on this? Tough question.
It's a good question, and I can elaborate. It is a big challenge. There's a couple of things. So there's some more simple solutions, like making sure that the contrast is good enough in the user interface, and that people can use the keyboard for certain operations. And there we make some minor efforts, I would say, to make sure that this is compliant. And then, of course, there is the real challenge, which is how do you make a 3D application accessible? And we ask ourselves those questions, but these need to be answered in a larger context, I think, because there are other 3D tools that we have, right, like CityEngine and Scene Viewer, and yeah, I think everyone knows the challenge, and everyone is looking for ways to solve it, and it's an open question, but it's definitely not something we're taking on our own, but we know the challenge.
I think that's why I'd really like to see that question in one of the booths, because I think then you have a bunch of different areas being able to weigh in on this, right? Because yeah, it isn't just something that's specific to ArcGIS Urban, but it's sort of generally, a challenge. All right, then next. So what's the minimal version of Enterprise you plan to introduce Urban? Can you answer that?
I can I can give a vague answer, and it probably is not the answer people want to hear, but it's probably going to be a very recent version of Enterprise that we start with. But again, we are investigating, and we are looking at our options, and we haven't made a decision there yet.
Okay, and last question, unless some more come in. Will it be possible to port an ArcGIS Urban deployment in AGOL to Enterprise in the future? So if we work on a AGOL solution now, can it be ported in the future? Something for Esri planning for municipalities where US AGOL data store is a potential issue.
This is a very good question, and I will maybe answer the more general question, right? Can urban deployments be ported? Because we also see this between different development environments or from one account to another account. So you can do this now using the API and creating a Python script that does it for you. But we are planning to support this in the future, at least maybe provide this Python script to do this with the API, because this is a question that comes up a lot. It is an important use case, so that you can set up your urban model in one place and then port it to another place where you're going to end up using it. So it's definitely something we are planning to support in the future.
All right. So I think you managed to answer all the questions, unless something else comes in the next few seconds. And yeah, if any other questions pop up later, again, feel free to stop by the Smart Cities and Digital Twins booth, where we'll have some, I'm not sure if you're there all the time, Michael, but where we definitely have some other ArcGIS Urban experts in the booth as well that can help out. So yeah, then I'd say that's that, right?
Yeah. Thanks everyone for joining this session and for the very good questions.
Thanks a lot, everyone.